It's a warm, lovely day, and I'll try to keep us all awake if I can. And our reward at the end of this lecture will be a reception to be held outside. So let's rock and roll. Our topic tonight is sustainable stewardship, and if we could have the lights off, it'll assist us all in sleeping more soundly. And I'll be taking pictures of those who nod off and posting it on the internet. Before I actually get into this talk, though, if you will indulge me for 5 quick minutes, I know that there's folks here, many of you that are involved in graphics and in paper conservation and photographic related matters. If I could just put that other hat on for just a moment, I wanted to take just 5 minutes to familiarize you with something that we are very proud of at the Image Permanence Institute that we have created as a learning and teaching, primarily teaching tool for the identification and understanding of graphics materials, images on paper, starting back from woodblock prints and going forward to the latest digital materials. And in other words, it's process ID. It's a teaching tool for process ID. And it's to be found on the web at graphicsatlas.org. And this is Graphics Atlas, and I'll give you just the briefest tour of it. Everything on Graphics Atlas is arranged around processes. You see you have pre-photographic, photomechanical, photographic, and digital. And within each one, for example, within photographic processes, there are individual examples. And you can browse them by name if you already know that you want to explore a chromolithograph, you can. Or there's a visual browser, or you can say, does my thing look like this? So if your thing's a mezzotint, you think, yeah, okay, let's explore the mezzotint. And that takes you to one of the 3 ways to look at each individual material. This is called the guided tour. And the guided tour has selected images that tell you about this particular graphic object that you're looking at, and things to notice about it, the prominent features. So you can click through them and etch lines, the characteristic rocker markings of the mezzotint, and so on. You can look at a little video of the surface, and when it works, yeah, there you go. All the materials, there's a little video back and forth. Mezzotints are matte surfaced and have no reflections. So if it were glossy, you would be able to see that. It's a bit analogous to holding in your hand. And there's a neat little thing here where if you click full screen, all of those things, all of those views in the guided tour, you can click through one by one and see it full screen. So that's the guided tour. And you can also do something called compare view, where you can compare one process to another. So if you wanted to compare a mezzotint with, I don't know, let's see, a cyanotype. What you see is there's a dimension bar that shows you every image on this, and you'll see that there are about 22 images of each process. Can be, they're made in exactly the same way. So in the compare view, there's a little driver's console here where you can control whether you're looking at the front or the back. You can change the angle of light. So if you want a raking light to see the texture, you can do that. You can do different magnifications, and you can also see cross sections labeled with each one. For example, here in the cyanotype, you see the ferric ferrocyanide image in the paper fibers, and there's the ink on the mezzotint and so on. And there's a very neat full screen view for the primary thing. And if you use the arrow keys on your computer, you can cycle through, you have to be on the surface, you can cycle through all the magnifications and all the views and change whether you're looking at it from a 45-degree angle, from a 0-degree angle, or from a 90-degree angle. So it's an interesting virtual print shop, or a virtual lab where you could study prints under the microscope and really begin to explore their characteristics. And the third view in here is called identification. So that's a single page that takes you through. This is not Graphics Atlas's fault, but what we will do is start from home in case it is Graphics Atlas's fault. So if you wanted to find out how to identify for example, an inkjet print, you can do that here. So there's a single page telling you all about the key characteristics of inkjet prints, different dot structures that they might have, different back printing. There's your little video of this particular inkjet print and talking about abrasion and so on. So some of you may know Bamber Gascoigne's book, How to Identify Prints. This is a kind of electronic version of that very thing, and I think it's very good for classroom teaching and so on. So thank you for indulging me on that commercial, graphicsatlas.org. And now to the main event, Sustainable Stewardship. And the subtitle is really the important one. It's talking about the new thinking on preservation environments and building operations. Are there any building operators in the audience? Anybody wants to, be singled out for building operations? No? Sort of. Well, everyone has a house, so they're building operators for that. But anyway, let's plunge on. This is what Bobby told you about us at the Image Permanence Institute. And let me take the opportunity to acknowledge the sponsors of NEH, IMLS, Andrew W. Mellon Foundation, and the Society for Imaging Science and Technology. They are the people that have made IPI and all of its work possible. What I'm going to try to do in the next little while is talk about some of the ideas that have become current in our work and the work of others. Concepts, talk about some of the tools and approaches to managing environments, and focus in on a couple of projects that we have been involved in, major ones at the Library of Congress. There's a project that we're embarking on here at Yale University that is funded by IMLS, and in that project we will be exploring the concept of saving energy by shutting off air handlers during unoccupied hours in library stack spaces. And our sandbox for this particular fun day at the beach will be the stacks here in Sterling Library, and which are served by 6 different air handling units. And we'll be having fun with that. And I will also tell you about a similar experiment that we have begun at the Library of Congress. And then I wanted to share with you the opportunity to take a look at some new museum storage buildings that are extremely low energy that have been built in Denmark. I could go on about them for a very long time, but we'll get to that. Here's a little part of this is going to be a primer on this whole subject. I recently had the opportunity to visit 10 historically black colleges and universities and to consult with them on the environments in their special collections departments of their libraries. And this is the library at Prairie View A&M University in suburban Houston, Texas. And it's a nice new building. It's got great collections. It was built in the 1980s. And this view has a little symbolic thing going on, because one of the things that you need to know about this whole subject is that the outside climate is hugely determinative of what the inside climate is like, what are the possibilities for saving energy. And the two things that combine to create the inside climate are the outside climate and the mechanical systems inside the building. just pause to review some of the real fundamentals here. When you build a structure and have systems to control the climate inside it, it's fairly easy to control temperature. The machines to make cold and to make heat are easy to build and easy to control. The tough job is controlling moisture. And that's what we want to do in library and archive and museum environments, is we want control over both temperature and moisture. And it's the moisture part that's really the difficult one. And here is where the complexity with the outdoor climate comes into play. We pay a lot of attention in environmental management to this parameter called dew point. Now, dew point is the temperature at which moisture will condense out of the air. But dew point is also a direct measure of the amount of moisture in air. And since there's often too little moisture in the outside air or too much moisture in the outside air, depending on the season, how much outside air that comes into your building, and whether it's the right quantity of moisture, it has the right dew point, that's where the details get devilish. And the more outside air, here's a little energy note, just in general, you save energy by not running machinery. And when you're bringing in more outside air, and especially when in the heart of the summer or the heart of the winter, when it's too cold and too dry, or too warm and too moist, that's when you spend a lot of money. So the more work you have to do on outside air, the worse it is for energy. Well, as far as the collection is concerned, and we're back again here at Prairie View A&M in that building, if you go down to the basement of that building, that's where you see machines like this that make the environment inside the building. This is what's called an air handling unit. And what you're looking at is, it's a big sheet metal box. There's a fan in the middle. Straddling each side, in this particular case, are these pipes. And behind and inside the machine is a cooling coil and a heating coil and a fan. Those are the real fundamental elements. And it's this machine's job to provide a human comfort environment and to provide a suitable environment for the collections. And this is a rare sight. I'm going to show you one of the rarest sights you've ever seen. There you see a meeting of the minds between the library director and the building operator together in the mechanical rooms. And you're going to hear from me that the thesis of my work is that the preservation of the collection depends hugely on the storage conditions. I could talk till you were all bleeding at the eardrums about the ways in which temperature and humidity conditions really do affect the conditions. But if you'll simply grant me that, if the jury will stipulate that, we can go on to talking about the other stuff, okay? And so here you see what ideally has to happen. My thesis will be that we can no longer, if we're in the preservation or we're in the collections part of a cultural institution, we can no longer be an effective advocate for the health of our collections in this way unless we have a kind of meeting of the minds. And it was really funny, the fellow there had worked there for 11 years, that'd be the guy in the blue shirt. He is explaining a panel of controls. The machine I just showed you, the air handler, that is controlled via a computerized system, and that's like the little junction box where all the wires that are connected to individual valves and dampers go to sort of a concentration point, and from there they are sent to a computer. So this fellow can operate this library's systems from his office, which was across campus, or anyone in the whole Johnson Controls organization, could be thousands of miles away, can see what's going on and operate it. This is what's called a BMS, or a building management system, sometimes called an energy management system. The funny part about getting everybody together to see this is I insisted that the library directors and the archivists go on a tour of the mechanical rooms. And that's what's so rare about this. At one moment I said to the guy here in the blue shirt, I said, wow, I guess this is the biggest crowd you've ever had down here? And he said, this is the only crowd I've ever had down here. And I did this 10 times, and sometimes I had to drag these library directors kind of kicking and screaming through the mechanical rooms. But it's extremely instructive. It concretizes what's going on, and this idea embodies the whole thing. Now, one of the things you'll hear me say in just a moment is how complex these systems are. And I explained that there was a computer somewhere where you could see and visualize the moving parts of this, the building management system. This is what one part of such a system would look like. This is the schematic part, where every moving part is represented. And if you look closely, there are little values there. This is what the operator of a building sits at a computer terminal and looks at screens like that. All right, now let's talk about sustainability and really get to the fundamentals here. Environments cost a lot of money. They burn a lot of energy. In many cases, that's fossil fuel energy. And as a rule of thumb, you can think for every square foot of temperature and humidity controlled space, an average cost per year just for the energy, not for the salary of the blue shirt guy, not for the amortized capital cost of building it, but just the amount of electric and gas it burns each year is $4 per square foot on average. For example, the University of California, Los Angeles has 850,000 square feet of library stacks. So you begin to do the math and you're talking about big, big money. I just showed you an example of a building management system. One of the reasons why it's so rare that preservation, collections, staff like librarians and so on, and facility staff and building operators get together is everybody's job is very, very complicated. And from the building side, the buildings are really hard to understand. They're very individualistic. There are many generations of those building management systems. There's Band-Aids on top of Band-Aids. There are dumb systems designed from the beginning. There are all kinds of reasons why understanding them does not come easily. And no one should underestimate the reality that it's difficult. Now, I asked you to stipulate to me that environments do matter for the collections. And the points that are important in a sustainability context for that are, we've spent a long time, I'm more or less at the tail end of my career, but I've spent at least 30 years studying the ways in which materials deteriorate in the laboratory, causing them to deteriorate through accelerated aging, reading about deterioration, going to conferences, listening to people talk about the ways in which collections are harmed or helped by the environment. And what's the net result of all of that? I can say to you that most professionals that are in the preservation field or in the curatorial or librarian field would give less latitude for safe environments for collections than I think is real, than I think the science would support. In other words, there is more latitude to do different things with the environment. And I'll speak to that point a little bit later. But here's a crucial point as well, and that is, suppose we wanted to save some of that big money, some of the money we're spending to condition to precise temperature and humidity, all those square foot of libraries, of museum stores, of archival materials. How are we going to do that? What's going to be the problem standing in the way? What's going to be in the way is not the ability to turn things off, because that's 3 clicks on the mouse. You can shut it off with 3 mouse clicks and the password. That's the easy part, and that'll save you money. The hard part is knowing when to do that safely and responsibly for your collections. And who's going to be prepared to answer that? Is it going to be the facilities person? No. Is it going to be the CFO? No. Is it going to be the director or the dean or the chief curator or whoever? No, it's got to be the person who has the collections care responsibility, be they conservator, preservation administrator, or so on. Their guidance is critical. Their input is critical to achieving a sustainable condition in these cultural institutions. In other words, it ain't on those buildings, guys. It ain't on the CFO. It's on the preservation and conservation function. And they have got to step up, and they are the ones who are going to describe this envelope of reasonable, safe operation for the collections. It might even be better. Big money? Well, you be the judge. This is a woman that's an archivist at Woodruff Library in Atlanta, and to give you an idea, she's standing in an air handler. She's standing in one of those machines that make the environment. She's standing in front of a cooling coil that's 12 feet high and about 30 feet long, and there's another one of the same size directly behind this one. And so that machine, the cooling that runs through that coil, is provided by two machines called chillers that are of this size. So when I say we're talking about big money, you don't want to pay the electric bill. You don't want to pay the fuel energy costs for these things. Okay, so here's where it comes down to. The scope of my interest in talk in sustainability is not building the greenest, coolest new thing, but working with what we have. And that's going to be the case for quite a while. The question for large institutions is, how do we work with the buildings we have, the mechanical systems and collections that we have? In other words, we want to optimize them. And to me, this is where sustainability is defined in practice. What is optimal operation? Well, the environment is the best for the collection. It causes the least deterioration. It uses the least energy, least fuel, natural gas, electricity, and so on. That it's workable for the people who have to use the collections. It's workable for the workflows that the institution has to actually fulfill its other functions. The best systems, most sustainable systems are also maintainable and simple. I cannot tell you how often things were some designer's bright idea and they're turned off. They're turned off. I arrived here to find out that there have been layoffs in the facilities organization in this institution recently. And you're not alone in that at all. There's fewer and fewer people. They're stretched thinner and thinner. The systems are more and more complicated. There's a huge premium on simplicity and maintainability in all this. And finally, in some institutions, the structure itself is part of the collection. That's true for many historic homes and so on. Whatever the optimal solution is to operate these massive energy hog machines, it has to work with the structure. It can't ruin the walls, the building envelope, and it has to be working in harmony with the outdoor climate. Okay, well, that's the principles. Optimal, that's our mantra and our buzzword, optimal operation. And that was what we set out to do at the Library of Congress with the Mellon Foundation grant in 1999. And now we're in our 11th year of working with the preventive conservation staff and the architect of the Capitol staff at the Library of Congress. And I'd like to just share with you a little bit of what we're doing and what that has meant, the lessons we've learned. The way we've worked at the Library of Congress is we work on two fronts, the energy front and the collections environment front at once. So we place data loggers. This device here is called the PEM2. That's a temperature and humidity recording device. It's about this big, and it's battery powered, very portable, and you can retrieve the data from it by putting a USB flash drive into a little port on the side, and it will write a text file on that USB flash drive that tells you the temperature and humidity conditions. And so they have approximately 150 such devices scattered in the three principal buildings of the Library of Congress, and they tell us what the collections are experiencing. At the same time, we're measuring inside selected air handling units, those machines that make the climate. And there you see June Wheeler, by the way, who's a partner in an energy consulting firm that we have worked with called Herzog Wheeler and Associates. June, by the way, 1981 Yale alumna in architecture. Yay, huh? Local girl makes good. And that is Jeremy Linden of the IPI staff. I'm sorry, I'm messing it up here. And they are standing outside a large, but by no means the largest ever air handler that serves exactly half of the Adams building. The Adams building is the 1934 building on Capitol Hill. It has 12 stack levels. I don't know how many million volumes of books in one giant block square building. And there are two air handlers that serve all those book stacks, a north unit and a south unit. And so we are measuring the amount of energy that is consumed by the north or by the south stack air handler. And what we've been doing recently is turning it off at 8 o'clock at night and turning it on at 6 o'clock in the morning. Shut off, dead, end of story. There are no staff in there at that time, and there is no reason to have ventilation. So just by dint of this, we have estimated that if we did that year-round, if we turned it off every night and turned it on again every morning, year-round, it would save in this unit alone $80,000 US in fuel energy. So between the two units, if we did it in both sides, it would be $160,000 per year just by turning it off at night. So, and when I say it's big money and big savings that are possible, it really is. But you have to do it safely. The trick is what happens when you turn it off. And in the real world, sometimes very little happens. Happily, so far, that's been the case in the Adams South stacks. You can see a tiny little blip, but we have the ability and the technology to know what that means to the collection, and it don't mean much. So as long as the collection's cruising along happily, why not put that $80,000 in your pocket each year? And just think, there are two other buildings there in the Library of Congress. One of them, called the James Madison Building, is the newest one. It has 42 air handlers in the penthouse and another 16 air handlers in the basement. You get the idea. I mean, I'm not trying to oversell this, but there's real money involved, and it's really worth thinking about. Well, how do you address that critical question of when is the collection, as a result of anything, as a result of the phases of the moons of Jupiter, or you turning things off, or just the way they did it, or just the way they've always done it? The problem is one of prima facie understanding what the collections are experiencing and what that might mean in terms of deterioration. And this is give you an idea of how that judgment call has been made, not only here in Sterling, but in many institutions. Hundreds of different institutions are using our environmental assessment methods, which begin by collecting temperature and humidity data continuously. And by the way, you ain't got no data, you're just punk, you know? What's that saying, you know? Money talks and something else walks, you know? Data talks and everything else walks. If you don't have data, if you don't know what your collections are experiencing, you're just kind of out of luck because you can't get to first base. I know there's a lot of Red Sox fans here, right? You would understand that analogy. Without temperature and humidity data, you don't get to first base. All right. So when you have temperature and humidity data, a lot of people think that they're able to then understand what the collections are experiencing. Yeah, right. That's what we spent 25 years of research to try to figure out, is that surely there are ways to take that basic information about temperature and moisture and then derive something that's more meaningful to us, that helps us understand whether it's good or bad, or precisely how good or bad it is for collections. So here's a kind of console view that you might see. These are the different spaces. Here are forms of deterioration that can affect cultural heritage objects. Natural aging is slow chemical changes. That's a big one for libraries. Mechanical damage, that's due to the swelling and shrinking. That's very important for objects made of wood, or objects like paintings, or ivory or bone, or lacquered objects, things of that kind, where the relative humidity of the air determines the moisture content of the object, and through a dry winter or a damp summer, the object will expand and contract. How much it expands, how much it contracts, and how big that excursion is between its extremes of expansion and contraction. Those are parameters which you can use to manage the environment. And so then there's mold growth. Mold will not grow under many common environmental conditions. We all know that damp conditions promote mold growth. So, and then finally there's metal corrosion, which again requires a certain amount of moisture. Well, the sort of console view to tell you what the collections are experiencing, one part of it can be boiled down to idiot lights like this. Red, bad. Green, good. And okay. So you can see it, you're just like, okay, there it is. But if and it's also dependent on what period of time that you're looking at. If you want a little bit more nuanced understanding of how good or bad the environment is with respect to these things that are critical to collections care, then you look at these numbers, which we call the preservation metrics. And these numbers are derived from the raw temperature and humidity data. And each one of them, I'm not going to explain them in detail, but that's the one that relates to chemical aging. It's very important for fading of dyes and degradation of paper. That's a factor that tells you whether mold would be possible, and when it's in red, it says, pay attention to me. These particular spaces are all problematic from the natural aging point of view. One of them is beginning to be problematic from the mold point of view, and several of them are problematic because they get too damp. Well, I show you this only that to explain that there are ways now to use quantitative quality control metrics to control preservation environments. And when they're in use, they work. And we've been using those for a long time. Now, if you want to, here's the really important lesson that we've learned at LC. The people who, nobody raised their hand to say they were a buildings, facilities type person, right? If you're there, you're probably going like this now. Let me say something sort of pejorative and stereotypical about that role. It's not really pejorative, it's real life. If you or I were in that role, we'd be doing the same thing, which is that when you think about environment, they think about environment as a project. Environment is, yeah, well, we'll get the equipment to do the job. They don't think about it the way I think you should approach it, which is as a process. Really, facilities people, it's either a project that has to be designed and built and scoped and budgeted, or it's a trouble call or a comfort complaint. That's all there is. There's no look at it every day, see how it's doing, or look at it every month. It's a project, or it's a trouble call, or it's a human comfort complaint. And humans can use the telephone and they can call up and say, I'm too hot, I'm too cold, and that will drive the actions. That's one key feedback mechanism for the building operators. But the collections, they lost the number. I mean, it was so heartbreaking. They lost that building guy's number. They had it written down on a Post-it note and they stuck it somewhere, and now it fell off, and now the books can't call anybody anymore. So that's if you're going to address and change that circumstance, you have to go after it. It's a process. It's people getting together and talk. It's not a numerical specification, by the way. Managing an environment is not calling up your buddy at the other conservation lab and saying, well, what do you do? Well, we do 70-50. Okay, that's what I'm going to tell the architect we want. That isn't managing your environment. It's not a numerical specification. In fact, no single environment is best for every kind of object. So it can't be approached that way. And really the way to think about environmental management for preservation and sustainability is by analogy to modern manufacturing. Think about the way that automobiles are manufactured. And famously, even though Toyotas have had a lot of problems lately, people, did you read that in the paper? People still buy Toyotas, okay? They're not hurting. Akio Toyota is not about to commit seppuku because its gas pedal's stuck a little bit. They still sell them, and people still buy them. Why? Because they're really well made. And the manufacturing prowess of Japan is well known, and they invented these concepts of continuous improvement in many cases. And if you're a modern manufacturing is done on these ideas, that it's never finished. It's a process of continuous examination of the production line, of the costs that go into producing the product. It's a constant reassessment of quality control. And if we can make that analogy, the environment is something that's manufactured every day. Down there, those machines, those AHUs, they're not stamping out widgets, they're stamping out temperature and humidity conditions. And if we don't pay attention to how they're working, we're not going to ever get any better. So what's preservation's role in this modern manufacturing process, if we can make that analogy? The preservation role is as designer, because after all, it's not the facilities, it's not the library director, it's the preservation and conservation role to say what the environment should be, to lay out its key points. And then it's up to other people to manufacture it. But then they have another key role, which is quality control, which is what I just showed you with using the metrics. And you know what? Metrics are found in every area of manufacturing. And you can't improve automobile production lines unless you have some way of measuring defects and reducing them. And so you're part of a production team if you're in the preservation world, and that production team is making the environment, whose goal is optimal operation. Remember all those things working together in harmony? Woo, it just gives me goosebumps to think about it. But the participants in this process are the collection care professionals, the building operators themselves, the people who love and own the collection, the curators, librarians, archivists, and the staff, and then the administrators who oversee the whole thing, including the money people. And they all together share the responsibilities for stewardship of the collections, for cost control, because people are getting laid off because these systems are chewing up too much money, and for sustainability in the sense of being a responsible global citizen. I mean, it should bother everyone that if there's unnecessary energy waste, it is harming the planet, and it is spending money that could be used for much better things. I had to throw this in. I'm a former English major, and I love that analogy of manufacturing, and continuous improvement. And today I got this email, and I had to throw it in here. At RIT, where I work, there was an email advertising RIT's Lean Six Sigma Yellow Belt Certification Program. Now, have you all had that conversation with somebody, and you're saying, well, what do you do? And they say, I'm a Six Sigma black belt. You never had that conversation? Well, let me break this down for you. Okay, you know what lean is? Lean is like in this is manufacturing jargon. And this is where manufacturing is. If you want, we're a school that teaches real place manufacturing as much as we got left in this country. And lean manufacturing means you don't have any unnecessary parts inventory and all of that. Six Sigma, everybody in tune with Six Sigma? How many Sigmas you got here? Seriously, do everybody not know what Six Sigma is? How many people not know what Six Sigma is? Oh, God, you people are hopelessly out of touch. Yeah. When you do real quality control and you have those measurements of quality, like you're making widgets, Six Sigma means sigma is a measure of the number of wrongly manufactured parts, for the sake of thinking about it. And Six Sigma is 0.00001% of parts are made in a defective manner. So if you're Six Sigma, like if you work for Motorola making cell phones, Motorola is obsessed with Six Sigma. There are people whose careers are Six Sigma. And so many so that they had to have like Six Sigma newbie, white, and it's like the dojo where you're learning karate. First you get the robe and you feel all self-conscious, and then you get, what's the first belt? You get white belt or something? And then you progress up through brown belt, yellow belt, and if you're black belt, and then, so like this program here that they're advertising in emails in my campus is like, yeah, you can sign up for this 3-day course to learn how to do quality control so that you are at 0.00001 defects. Okay? So that manufacturing today does embody, if you read through the text at the bottom, it does embody complicated things done cooperatively. And my thesis here in this talk is that that's the way I see institutional preservation and sustainability programs working together, to understand that it's a process, to understand people's responsibilities, and people hold up their end of the deal. It's absolutely hopeless, by the way, to expect that facilities people would understand collections, care, and preservation. But they need to know enough about it that they can function as part of the team. And therefore, we as, well, this is Chip and Kevin. This is part of the Library of Congress project, too. I mean, when we first started there in 1999, we did not have wondrous cooperation from the building operators. But now we do, and it's really proof that, I mean, now when we work there, and these guys take care of the Adams building, and they are the front lines of sustainability in the Library of Congress in this respect, that if anybody's going to save the $80,000, it's going to be Chip and Kevin. And they have to understand what's going on, and they do, and it's a real pleasure to work with them. So I know the process can work. And the man in the right on the black is there. That's Peter Herzog. He's the energy specialist on our team. And the person on the left is works at IPI, Jeremy. He'll be working here in Sterling. They are standing in that air handler that serves Adams South. And that gives you some idea that that is a large machine, and indeed it is. And that is Ben Ballman. He's the preservation liaison for the project. And he's pointing to one of our data loggers that is helping us to understand when the system goes on and goes off. So I wanted to emphasize that the preservation role in this, you don't have to know you don't have to know the building so well you can fix everything. You don't have to know the energy saving part so well that you can puzzle out the BTUs, but you have to know enough to be a team player. And you do have to take possession of gathering data and using these metrics. And you do have to know enough about your collection to know what its particular needs are. And you can't just read it in a book and so on. That's the data logger I was talking about. Now I'm going to beat up for a while on the need to have a close idea of quality control. Most people who collect temperature and humidity data just see a graph like this, which is impossible to understand and analyze. Yes, if you've been doing it for 15 years, you get some idea. But it's a far cry from what I just showed you. And a lot of people's idea about the environment, and this comes from the museum world, is that the ideal environment for collections is very steady. It's about 70 degrees Fahrenheit, comfortable for humans, and doesn't vary very much. and it's 50% RH, kind of the middle of the humidity range, and it doesn't vary more than, say, 5% up or down. That, you might say, is the current museum standard. Next Monday and Tuesday is a meeting, a very high-level summit meeting at the Museum of Fine Arts in Boston by museum conservators and others. I'll be attending. I'll probably have to wear a helmet, but I will be attending. The whole idea is that even for the real high-end art museums, this hand-me-down standard is under attack. It's not workable. It is good for one thing. 70 degrees, 50% RH is not the ideal environment for your collection. It has, however, one absolutely useful feature. If you're going to be exhibiting stuff, it's convenient for the visitors who come to the exhibit. If you're going to be putting different types of objects together, the 50% RH level is probably the best compromise for showing different kinds of objects. But that's as far as its beauty and wonderment go, because, as the next dot says, it's mad money for most climates. It really is very expensive. It's kind of the enemy of sustainability, because if that's your position, you want it steadily 70 degrees and 50% RH, you're kind of locked out of the sustainability game, and you're paying mad money for that. Mad money in the street sense of that's a lot of money, and mad money in the other sense of mad, like you're mad if you do that because, bah. And it's, like I say, it's incompatible with sustainable operations. And here in a library, 70-50 is really bad for library collections because it's too warm. You're cooking the books. I talked about the metrics. They really allow you to do that. And I wanted to point out another website that's very instructive called dpcalc.org. And this is a website that we created where you can explore the interrelationship between temperature, humidity, and dew point. And you can see on the right-hand side those idiot lights and the values of those metrics. And you can see how there is no one perfect environment. There's a continuum. And some environments are better for preserving objects that might degrade through spontaneous chemical change, like paper and textiles. Some environments are better for other kinds of materials or assemblages of materials. And you can explore that here. And it's a very good teaching tool. Tara was saying to me, Tara Kennedy, the Preservation Field Services officer here in Sterling, was saying to me just today, this is, if you don't know this, you don't know nothing. Because this is the fundamental relationships that guide the whole thing, whether you're trying to make the environment or you're trying to understand it. Anyway, the bottom line in our 11 years at LC, and there you see Nancy Lev-Alexander, who's the preventive conservation supervisor at the library, together with Peter Herzog and Ben, who works for Nancy. And the lesson that we've learned is, remember going back to that optimal operation? If you think that your place might be, by chance, optimal already, forget about it. Just forget about it. That's one thing we've seen over and over again, is that you can safely assume it's not optimal unless you've really looked at it and tried to make it that. The last thing I wanted to share with you was a new idea that is particular, really, I think, to museum objects and particular to certain climates, but it's very interesting from the low energy point of view. The Danes, when the Arab oil embargo hit in the 1970s, the Danes had a reaction like, oh, we got to save energy from now on. And they've been at it ever since in a very, very serious way. Our reaction was, oh, gee, there's a long line at the gas station. I can't wait till that's over. Oh, it's over. Okay. And we went on happily ignoring the whole darn thing. And, it's interesting to see what you could do if you didn't do that. And at the National Museum of Denmark, they have a group of scientists and engineers that work exclusively with the idea of designing buildings from the ground up that are storage for archives and museum objects, and they use very, very little energy. And I wanted to show you two of them. One of them is in the town of Vejle in Denmark. It's a museum storage building that is a cooperative among 7 museums. And then its son or daughter, or whatever you want to call it, another building for another museum in another town that was designed along the same principles. So, hey, you know you're not in Kansas when you see a building like this, right? This is the Vejle Cooperative Storehouse. Doesn't look like much. It's not winning any awards for landscaping, I don't think, either. It's not exactly the architectural triumph of Europe, but that's what it looks like on the outside. The really cool part, and this is what it looks like on the inside. It's 600 square meters of about 30 feet high ceilings. It's a one-story building. It needs to be the kind of very low energy building that it is. I'll explain that in a second. But that gives you a feeling for the kind of objects that are there. The Vejle Environment is completely, the environment inside it is a prize winner. On our metrics, and by any estimation, it is it's a champ. The RH is steady at about 55% all year long. The temperature varies. This is a basic design. The RH is steady and the temperature varies. And the temperature goes from about 45 degrees inside in winter to about 65 degrees in summer. And there are never any violent spikes in relative humidity because the interior walls, which are made of a special concrete, and the collections themselves to some degree buffer the relative humidity. Here's some of the secrets to making this building do its magic. It has no outside air. There's no intentionally introduced outside air. From leakage, the doors opening, and so on, they have measured it to be about 1.5 air changes per day. So the inside air is replaced by outside air only 1.5 times a day. Does that sound like a lot to you? A building like this probably undergoes 17 to 20 air changes per day. The room we're in. So that's very low. And as far as quality goes, the TWPI is over 100. Here in Sterling, most of the TWPIs are about 50, 55. There's very little dimensional change because the RH hardly varies at all throughout the year. There's no mold because 55% RH won't support mold. And here's the punchline. Here's the money shot. Total energy cost, $3 per kilowatt hour. $3 a kilo. Okay, I'm screwing up my money line. To operate the building, it costs $3 per cubic meter per year. And that, I mislabeled the slide, but it's $3 per cubic meter. Now, it's a floor area of 600 square meters, and it's 30 feet high, so you get the idea. But that is peanuts. It is peanuts. And another concern if you put all your museum objects in a closed box like this, how come it doesn't foul its own nest? Doesn't the collection objects produce pollutants? And by careful selection, you'll notice it's basically all metal except for the collections, all metal and concrete. All the finishes are selected so they don't outgas. So it doesn't foul its own nest with pollutants, and they've actually made these measurements. This is a slide that came from those guys. And here's the mechanical room for this very large building. It has a tiny little desiccant dehumidifier, this thing. There is an air handler. It's a little bit different scale air handlers, the ones I've been showing you. And it has no cooling. The building has no cooling. There is no way to cool the building. The building is cooled because it sits on the ground. And in the winter, the concrete floor adds a little heat, and in the summer, the concrete floor acts as a sink for heat and actually cools the building. Now, part of the secret of this building is it works in the Danish climate, which is cool and damp and somewhat cloudy. I think the Cullens from Twilight, after they left Forks, the Cullens moved here to Copenhagen. You gotta go to movies and read teenage novels to get that joke. But anyway, it's cold and it's damp, but it doesn't get real cold and it doesn't get real hot either. And that's a similar climate to much of the northwest of the United States, by the way. And so this air handler merely stirs the air around. There's a fan with a tiny motor. There is a heating coil in there, but it doesn't go on hardly at all. And in fact, the heat generated by the air dryer is enough to both heat and dehumidify the building. And the lights are off most of the time. There's no one in there most of the time. And like I said, it just sips energy. And here's a building that was built along the same lines with slightly different materials in a town called Ribe. And this give you an idea, that's the relative humidity here. The dehumidifier failed, but it's flat 55% all the time. And this is just when the dehumidifier is on. Here's the temperature floating with the seasons, cooler in the winter, slightly warmer but never hot in the summer. Remember, they got a climate that doesn't get too hot in the summer and too cold in the winter. But there are ideas about this that could be adapted to many places in the US. And this is the energy used by the dehumidifier. So a very, very interesting building. And here's from their own scientists, these are the keys to building a building like that. They say low winter temperature is a benefit, but it doesn't get low by our standards. And that's good because it would have to begin to add moisture if it did. Dehumidification, they find, is cheaper than humidistatic heating. And the low ventilation rates, the fact that the building is fairly tight, keeps the outdoor pollutants out. And yet, inside, it's not fouled by collection-generated pollutants, although you do have to pay attention to what you make the building out of. And here's the key. The slab, the concrete floor, is doing all the work of heating and cooling it. And they've discovered that it's important that the floor not be insulated, but the walls, the side walls and roof, be insulated very well thermally. So when we come back and look at our own buildings, I think there's lots of lessons and lots of opportunity for sustainability improvements. And if you want to, last thing I want to show you is this little things to look at to save energy in a building like we have, and like most of our libraries and museums. Keys are you're not going to save money unless you understand how the systems work. Typically, there are low-hanging fruit opportunities. The things that consume energy are cooling the air and heating it back up when you don't have to in order to dehumidify when you don't have to. Running your fans too much, letting in too much outside air. And use the preservation metrics to really regulate the whole thing. So thank you very much for coming. I hope I didn't go too long. I did go too long, I'm sorry. So if you want to, if you absolutely loved this, if this was riveting to you, I mean, I know you're on the edge of your seat, like, what can I do now? Then you can go to our website, imagepermanence.org, and sign up for our exciting Climate Notes newsletter, which is a quarterly newsletter, e-newsletter, that discusses a lot of these topics in detail. So thank you very much.